Shannon's entropy is a measure of information or disorder. When the distribution is unequal, entropy is low. When the distribution is roughly equal, entropy is high. With multiple distributed data sources, it is difficult to infer the global entropy from the local entropies. Local entropies can be low, yet the combined entropy is high. Continuous entropy estimation in distributed data streams is even more challenging. Each node continuously receives new local data. Given a window of recent data in each node, we want to maintain an accurate estimate of the entropy in the combined windows over time. The easiest approach is centralization. Forward all updates to a central node and compute entropy. This requires a lot of messages and can be infeasible when nodes have limited battery power or when data rates are very high. CIDR is a communication-efficient entropy estimator. Given user-defined constraints, CIDR provides an approximation H0 of entropy while attempting to avoid communication. For example, this is an approximation with absolute error-bound epsilon. This way, we reduce the approximation problem to a threshold monitoring problem. If the approximation is sufficiently accurate, simply output H0. If not, update the approximation and the bounds. We use geometric monitoring to perform threshold monitoring. First, we express entropy as a function of weighted averages of local probabilities. Second, we exploit concavity of entropy to find a suitable convex set C, such that if local probabilities are in C, then their average is also in C. This converts the global approximation bounds to a local constraints that node can check independently. The monitoring algorithm is conceptually simple. Each node checks if its local probabilities are in C. If so, no communication is needed. Otherwise, the node notifies a coordinator. The coordinator will update the approximation or otherwise resolve the violation. The devil's in the details, and the details are in the paper. We evaluated CIDR on the CTU13 router netflow dataset. CIDR reduces the number of sent messages by roughly 2 orders of magnitude compared to a centralized approach. We also evaluated CIDR for load balancing and error quality monitoring tasks. Thank you for listening. Please see our paper for details.